Analytical circuit analysis, B and B Tech students, transient response units. We see topic sinusoidal input response. Manager welcomes you all. In this unit, we see response with sinusoidal sources. RLC series circuit. Formula is I of t steady state is equal to Vt divided by root of r square plus bracket of omega l minus 1 by omega c square into sine omega t plus phi minus tan inverse of omega l minus 1 by omega c divided by r bracket and whole bracket shown in notes. In a serious RLC circuit circuit problem with R is 100 ohm, L is 0.1 Henry and C is 50 microfarad. Has sinusoidal voltage source V is equal to 100 sine 1000 t plus phi when phi is 90 degree. Find the current response assuming no initial charge on the capacitor. Find the two constants. So apply hint. Find two constants. Apply to initial conditions. Given values for phi is 90 degree, C is 50 microfarad, omega is 100. That is V is Vm sine omega t plus phi. L is 0.1 Henry. VTH is 100. R is 100. Put that values, given values in RLC circuit I of the steady state response with sinusoidal formulae. Sinusoidal formulae is I of the steady state is equal to VTH divided by root of r square plus bracket of omega l minus 1 by omega c bracket square and sine bracket of omega t plus phi minus tan inverse of omega l minus 1 by omega c divided by r and whole bracket, that is RLC circuit formulae. Formula is shown that nodes put record values VTH value and 100 and then R value and L omega L value and omega C value. All values is given in circuit. Omega T. Then angle is 90 degree. Put record values in that formula. We open I of t formula. I of t response, that is response of steady state RLC series circuit with the sinusoidal input source. We open formula. I of t is 0.7808 sine of 1000 t plus 51.35. Finally, we obtain I of the steady state formula. RLC series circuit transient response formula we already known, or I of t plus L dA of t divided by dt plus 1 by c integral I of t dt. From this equation we obtain m1 m2 values of minus r divided by 2l plus root of r square divided by 4r square minus 1 by lc. I of t is a e power minus m1t plus b e power minus m2t. In these equations we apply 0 plus conditions, that is initial charges no. Initial charge conditions I of 0 plus is a e power of 0 plus plus b e power of 0 plus. That is one equation. Then go to another equation is or I of 0 plus plus L dA of 0 plus divided by dt plus 1 by c integral I of 0 plus dt is equal to Vt. That is dA of 0 plus dt is V divided by L. V divided by L is obtained. Differentiate the above equation or I of 0 plus L dA of 0 plus divided by dt plus 1 by c integral I of 0. That equation is differentiate dA of dt divided by dt is we obtain a into we obtain equations I of t is a into some number value into e power of say minus m1t plus b some number value into b e power some number into e power minus m2t. We obtain at t is equal to 0. Condition is applied in dA of dt equations. We obtain one equation dA of 0 plus value is v divided by L is obtained. That is third equation. 2 and 3 equations solved for A and B. A and B values are obtained. That is steady state conditions are obtained. I of t is a e power minus m1t plus b e power minus m2t. That is transient response analysis equations. We obtain m1 value is minus 276.5, m2 value is minus 103.5 and A value is 0.161, B value is minus 0.771. Transient response with sinusoidal input sources response as total response as transient response plus steady state response. I of t is transient response plus steady state response. Transient response is 0.161 e per minus 236.5 t minus 0.771 e per minus 73.5 t plus steady state response 0.781 sin 100 t plus 51.4 1000 t plus 51.4. That is answer. Response RLC series circuit with sinusoidal input sources. That is transient response analysis topic with sinusoidal response sources. Transient response analysis I taken class 82 to 106. Kindly use these classes at man engineering link. Thank you. I explained previous class noted how to find M1 and M2 and A and B values. Kindly see this class notes at man engineering.